Here's a quick problem, but very important. Octet rule, we're going to illustrate that. All of these trying to achieve the electron configuration of noble gases, and that is the octet rule. All right, so let's see how calcium does it. Calcium is an alkaline earth metal that is right here in group 2. So that 2 tells you the number of valence electrons. We also know all of those elements, and then the electron configuration of Ns2, and calcium is also in that group, so it's going to have 2 valence electrons. Calcium's dot structure looks like this. Right, it's a metal. Metals will tend to lose those electrons, those valence electrons, and by doing so, it will look like it'll become a 2 positive cation, but when calcium loses those 2 electrons, it's going to look like argon. All right, it has achieved the octet rule. Next, let's go on to aluminum. That's in group number 13. So that tells you aluminum is down here. Don't look at the atomic number. The group number, the last digit will tell you the number of valence electrons. So aluminum has 3 valence electrons. All right, all of those main group elements in group 13 are going to have an electron configuration of S2 because they've passed the S's. Those are full. And then P1. So 2 or 1 plus 2 is 3. They're going to have the 3 dots there, the 3 valence electrons. All right, aluminum is a metal. It's going to tend to, when forming ion compounds, it's going to tend to, let me read what this problem says. How many must an atom lose, right? So that's what we're talking about. It's going to lose 3 electrons, and by doing so, it's going to become an aluminum 3 plus cation, and when it loses 3, it loses 1, it looks like magnesium, loses another one, it has the electron configuration of sodium, and when it loses 3, it looks like neon. So it has achieved the octet rule by losing 3. All right, let's move on to lithium. Lithium is an alkali metal, so those are your group, not hydrogen. Those are your group 1 elements. So they're all going to have 1 valence electron. So the group number, the last digit of the group number, tells you the number of valence electrons, and that is because they all have common electron configurations that end in S1. All right, so lithium with its 1 valence electron, it's going to lose that one. And when it does that, it's going to become a lithium 1 plus cations. We don't write the 1. When it loses 1, it's going to look like helium. Loses that 1 electron, it's going to have the same electron configuration as helium. This one's easy to show you using an energy diagram. So there's lithium. It loses that 1 electron in the 2s orbital, and then it looks like helium, which looks like that. All right. On to the last one. Barium is also an alkaline earth metal, so it's going to look just like what calcium did here with its 2 valence electrons. Barium's got 2 valence electrons. Again, you can tell just by the last digit of the group number. It's in group 2, right? Same thing. It's all those elements are going to have its valence electrons. It's going to have the common electron configuration of Ns2. All right, so it's going to lose these 2 valence electrons. Why is it doing that? Why would it do that? Well, it's the octet rule. These metals are going to give up their valence electrons in order to look like the nearest noble gas, and for metals they tend to lose electrons. So 1, 2, looks like xenon, and it has achieved the octet rule. So I'll just write the answers clearly over here. It's going to lose 2, 3, 1, 2.